In this lab, we will continue with the passengers' data collected from public transport network around Auckland. We fitted the data using the decompose model, seasonal underscore decompose and HTL decompose, and we checked that the observed values equal trend plus seasonal plus residual values. And now in this lab we will check the stationarity of the values. Stationarity is a property of a time series. A stationary series is one where the values of the series is not a function of time. This means the statistical properties, mean, variance, etc., are constant over time. This means it will have no seasonal effects too. Forecasting a stationary time series is much easier and far more reliable. Statsmodels has tests for this such as adfuller, augmented decay Fuller test, IDH test, kpss, Kowalski, Phillips, Schmitz, Shin, kpss test. That's for the trend stationary. Our time series clearly has an increasing trend. So if you look at the trend, let's look at the trend. So this is the trend. So it has an increasing trend for seasonal decompose, and HTL decompose also shows the increasing trend. So our time series clearly has an increasing trend. So would expect the p-value to be much greater than 0.05, implying the time series is non-stationary. So if the p-value is much greater than 0.05, then it implies the time series is non-stationary. So let's have a look. Find the missing values in pre-COVID data. So we have pre-COVID data, and to check the number of the rows, the data rows, which is the missing values, we put in the square bracket passengers in thousands column dot is NA, open and close bracket, and that prints nothing. Then we check for stationarity. From statsmodels.tsa.stattools, import adfuller. Let result equal adfuller of passengers thousands. And then when we print the result and print p-value, colon percentage f. So in place of percentage f, we will have the result. So percentage result, and then square bracket 1. So the result is this one, but the p-value colon and then 0.991613. So p-value is 0.991613, and it is much greater than 0.05. So the time series is for pre-COVID is non-stationary, and for non-stationary means that the series is a function of time. That means the mean variance are constant, are not constant over time. This means it will have seasonal effects too. Okay, so this implies that it is non-stationary. And for the pre-COVID, we also did the KSS. I'll show that. So for the KSS, check for stationarity using kpss. From statsmodels.tsa.stattools import kpss. Perform the kpss test. Let result 1 equal kpss of passengers in thousands. Then we print the result 1 and the p-value colon percentage f, and that is percentage result 1 of array location 1. So is the p-value is 0.01 and it's less than 0.05, which shows that the time series is stationary. So the test statistics is outside of the range of p-values. The test statistics, which is 1.93 and so on, is outside of the range of p-values available in the lookup table. The actual p-value is smaller than the p-value retained. The actual p-value is 0.01. 0.05, and that is greater than the p-value retained. 0.01, 0.5 divided by 100, 0.05, 0.01, 0.025. So the actual value is the p-value retained. So the p-value retained is 0.01. Okay. So p-value is 0.9916. So this is not for kpss. This is not p-value. Yeah. So the actual p-value, which is and it is smaller than the p-value retained, and the p-value retained will be 1 minus 0.01. And okay, so so the time series is non-stationary. At the same time, if we check for the post-COVID data, find the missing values in the pre-COVID, post-COVID data. Post-COVID, we check that the post-COVID doesn't have any missing values. So this is how we do that. Post-COVID subset passengers in thousands dot is NA, open and close bracket, and it returns nothing. So let result equal adfuller of post-COVID passengers in thousands column. Print the result. Print IDF statistics colon percentage F, and that will contain percentage result array position 0, and that gives IDF statistics minus 3.237439, and print p-value colon percentage F, and that will have result position location 1, 0.017917, and we can see that 0.01797 is less than 0.05, so it means the data is stationary. The time series is stationary. And what does the kpss tell us for the post-COVID? Let result 1 equal kpss of post-COVID of passengers in thousands column. Print result 1. So the result 1 is here, and the print kpss statistics column percentage F, and in place of percentage F we have percentage result 1, and the array position is 0. And kpss statistics is 0.150545, and print p-value colon percentage F, and that will be result 1 of array position 1, and that is 0.1, and we can see that 0.1 is greater than 0.05, which means so the actual p-value, which is 0.05, is greater than the p-value retained. The actual p-value is greater than the p-value retained. So the actual p-value is 0.05, and the p-value retained is so 1 minus then the p-value retained is 0.1. So the actual p-value is smaller than the p-value retained, and the actual p-value is greater than the p-value retained. Okay, but the IDF statistics, it shows that the p-value is less than 0.05, which is a stationary time series. So post-COVID is the stationary time series, and pre-COVID is non-stationary time series. So in the non-stationary time series, seasonal will have effect, and in the stationary time series, seasonal may not affect. Seasonal will not affect.